Okay, and think I'm live now. So how are you doing? Good afternoon, good morning, good night, whatever you are, right? In this, if you can hear me, if you can see me, just come to the chat, tell me where you're from, tell me where you're watching this. Are you watching this on YouTube, on LinkedIn, on Twitter, on Facebook, wherever you are? Hopefully you're having an awesome day, right? So I was here this amazing afternoon. It's a little rainy here in Sao Paulo, Brazil, and I was having this nice conversation with my good friend Scott, right? And Scott, we're talking about the developer career. We're talking about skills, right? And we talk about the presentation that Scott has been doing. And Scott told me, I've got a presentation about reading code, right? I said, awesome. Can you show it to me? He said, very innocently, right? So, poor Scott. He said, oh, yes, I can show it to you. Let me just share my screen. I said, no, 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 no. Let's do a live, right? Let's just go live on YouTube immediately. And so he's a little bit worried about going immediately live. But, I see Evandro saying hello. So, hey, Evandro. So, just tell us, we just going to have this conversation, me and Scott, about the developer career and especially about this awesome skill of reading code. And let's see how it goes, right? So, without further ado, my good friend Scott Rishan. Hey, Scott, how you doing, man?
Hey, doing great. How about you?
Doing awesome, man. Don't don't be so worried about. We're just gonna have a conversation, right? Just for the whole world to see. Well,
It's just you and me.
it's just you and me and hundreds of other people watching online, right? So how about
Right.
that, right?
Not a
Hopefully.
problem.
Okay, that's great. So, so anyone here, if you are, I can see here some people already watching us here. That's great. Awesome. Okay, cool. Okay, so just tell us where you're from, what are you doing. So, Scott, let me just start. You said that you have this presentation about making sense of other people's code, right?
Right.
So one of the things that we're talking about is, um, a lot of times we just want to read the code that we wrote, right? We're not much into reading other codes, and especially, right? I think that developers don't like a lot this whole notion of legacy code, right? So why should we care about reading code, and why should we care about legacy code?
Well, um, because that's what you're going to spend most of your day doing. um, I get into it in my presentation, but yeah, that's what you're going to spend. I mean, before you can start writing something, you have to read to make sure that whatever you're writing is going to fit into what you already have.
Mhm.
And unless you're completely greenfield and have a you know an empty sheet of paper in front of you or an empty screen in front of you that you're you're just writing from, you've got to integrate what you're doing with something that already exists. So you're going to have to be reading something to know where your new stuff is going to fit in.
Mhm. Mhm.
And um, and I, I've I have a shelf full of books on how to write better code and better ways to write code and make things more effective and more clean and solid and whatever else you can think of. But I have uh, one book on reading code. And it's very helpful, but I find it odd that if we're spending most of our time reading code, um, you know I realize that we need to spend a lot of effort learning how to write better code so that it's easier to read. But that's not the world we live in. we've got to we've got to figure out how to read this code that someone wrote who wasn't concerned about whether someone else could read it.
Right.
So
And one thing that I always think about every time we talk about legacy code and about reading codes, one thing that I think about is that everything that we depend on is legacy code, right? So I mean, we're running things on top of an OS and maybe on top of a browser, and we're running the Java virtual machine and have hundreds of libraries that we might be using in our code. And all of this being code that have been written, sometimes like last year, sometimes 10 years ago, sometimes 27 years ago, right? And
sometimes
so
last week.
sometimes last week, right? But, but a lot of it has been around for quite some time, right? And we got to make sense of that code too, right? I mean, when you call a library, for example, we might need to take a look at what the guy wrote, and maybe that library exists for a long time. So when we mention legacy code, it's not necessarily this terrible thing, right? So I think legacy code is part of what we do, and everything that we do becomes legacy, right?
Yeah, yeah, really. I mean, if you hope, you hope.
That's what we hope, right? We want the things that we write to become legacy, not to just be destroyed the next day, right?
Otherwise, it's just going to throw it out next week, and why did I waste all my time writing it?
Right, exactly. Oh, exactly. Oh man, I cannot believe how many projects I'm working on that basically we work it so hard and kind of working late at night now that this whole thing was canceled and never saw the light of day.
Yeah.
So that was a very frustrating part of it. So we want our code to become legacy, right?
Yes. Yes. Yeah,
All right.
otherwise, it's you
Yeah.
want to have some staying power there.
Cool.
You want it to
All
have
right.
value.
Okay, so without further ado, so if you have any questions about reading code or about importance of developer skills, let us know in the chat or wherever you're watching this. You can just comment on the post where you're watching this. Hopefully, you're going to be able to see all that. Scott, how about you get started then, man?
Sounds good. Thank you very much. Okay, so the title of my presentation today is making sense of other people's code, and really, like Bruno and I were talking about, this is a skill that's underappreciated, and really it can set you apart if it's something that you really have developed the skill at doing. Um, this is pretty much my guiding principle. I heard a speaker say once that our lives change when our habits change. So my goal here is to help you learn some new habits so that you can have positive impact on your software development career. You know, develop those habits that you need to become what looks like a great programmer, right? Okay, so in 2004, Steve McConnell wrote a book called Code Complete. I highly recommend it. It still has some staying power. It's really it's a good book. But he referenced a study from 1964, and it measured how programmers spent their time in a given work week. And among the various things that they do, they spent 14% of their time reading code and 13% of it writing it. The rest was like meetings and distractions and other stuff. But he said that in his book that he hadn't seen anything to indicate that those numbers have changed significantly over the years. Now, a few years later, in when was that? 2009. Yeah, Uncle Bob released Clean Code, and he claims that developers spend 90% of their time reading code. He didn't reference any studies, but he's a pretty smart guy. I'll let him and Steve duke it out over the details. But IEEE did a study in 2017, and they claimed that nearly 60% of developer time is spent trying to understand programs as opposed to creating programs. So the point of all this is that you're going to spend at least half of your time reading code, okay? And like I was saying earlier, there are dozens of essential references that I could recommend that help you to write much better code. But how many books have you heard of that teach you how to read code? Really, I'll suggest a couple. But if we spend half of our time doing this, we really should do it well and know how to do it well and how to develop our skills so we can improve our ability to do it. And that's really what we're talking about today, okay? So first off, I'd like to know, what is it you need? What are some of the problems that you have? What what are you looking for when you're reading code? What are you trying to do? What makes it difficult to read code? Where do you get stuck? And if you put your comments in the chat, then I'll do my best to get to the answer the questions that you come up with as we're doing all this. So, like I said here, help me help you. Um, all right, so um, while I wait for some people to chat, let's talk about the difference between reading a book versus reading some programs. So this is one of my favorite authors, Ernest Hemingway, and working on some sort of manuscript. Reading code isn't the same as reading a book. You can sit down in a comfy, easy chair with a glass of wine and enjoy flipping through a good book. Um, I mean, you might need to remember some of the characters and the relationships, but unless you're reading a mystery novel or a technical manual, you really don't have to pay super close attention. But if you're reading code, you probably have like a pen and a paper at hand to take notes or to scribble, or you have a printout that you want to scribble your notes on and that sort of thing. You're going to use different tools and techniques to follow the flow, and it's hard work. Um, so, and if you're writing, that's a whole nother thing. Both prose and code take a lot of planning and rework. In fact, if you think about Ernest Hemingway revised his original manuscripts, I don't know, dozens and dozens of times before he released the masterpieces he ultimately came up with. And so, um, I I often tell my coworkers, yeah, don't think your first working solution is ready for production. You're not better than Hemingway. Okay, go back and refactor it. So, all this to say is that when we're reading code, it takes a lot more work. You're going to have to. I mean, it's like I said here, it's exhausting hard work to read code. What makes code hard to read? Think about the things that make code hard to read. Um, I wrote down a few of my ideas that I could think of. The first thing that makes code hard to read is somebody else wrote it, and you know, or maybe I wrote it, but I must have been drunk at the time. I don't know what I was thinking. Even if it was last week, what the heck was I thinking when I did that? Holy cow! And I will say that if you look at code that you wrote a year ago and you don't think this, then you're not growing as a developer. So you want to grow your skills as a developer. All right. Um, a lot of times people don't document their code, and so it makes it hard to flow. Or sometimes they do document the code, but the documentation is the code has changed and the documentation hasn't. So the documentation is lying. That can be frustrating. Magic numbers can be misleading or confusing. You got the same number appearing a whole bunch of times in the code. Do they mean the same thing? Maybe, maybe not. I don't know. Or people will reuse a variable. They have like a class variable, and then they'll have the same variable name within a method that kind of overwrites the class variable, and you don't know what you're using. The thing we probably run into the most are large classes or large methods that just stretch on for pages and pages. Or even like you'll have global variables, or another name for a global variable is a singleton. Yeah, yeah. I mean, it's just a variable that's used over and over and over. Or just bad names for variables can be frustrating, misleading, confusing. You don't know what it is you're looking at. Um, all that being said, if you look at this list, that looks like code smells, right? If you've done any studies on refactoring, you know that code smells are or how you know what to refactor. And really, if you have good code, it's easier to read, and so consequently, you'll have fewer bugs. Um, and if you think about it, we can't write good code unless we can recognize bad code. So being able to recognize code smells is an important way for us to make sure that we're not creating code smells in the code that we're writing. So we can recognize what we're writing. That's a code smell. I need to go and refactor that into something that's better. Um, you know, when if you want to be a good writer, you'll want to read other people's good writing so that it'll improve your ability to write. Same way, if you want to be a good code writer, you'll want to read good code and you want to recognize the bad code so that you can get rid of it.
So Scott,
Now, yes, sir.
yeah. So you asked about people in the chat here.
Yeah,
So Andres is from Uruguay and he's actually in Lima, Peru right now. So he says hi, and he says usually it's difficult because the other developer or even the younger you made assumptions about what's obvious, right? But
yes,
it isn't, right? So you don't have all the context.
right. That is a brilliant observation. That context is what makes the difference when you're reading code because you don't know what the other guy was thinking. That's really what you're doing is when you're reading the code is you're trying to get into the mind of the other guy. What was he thinking when he originally wrote this? And and why did he do it this way? I I remember there was a project I work on many years ago, and someone else I I suggested we all shuffle around so that we don't have silos of people knowing things, so other people can work on other projects. And nobody liked that idea except me. So I got pushed off onto the project nobody wanted to do, and somebody else picked up mine. But that guy would come into my office every now and then say, "You did it again. I thought you were doing something really stupid, and so I went and changed it. And then I spent the rest of the week trying to clean up the mess, and finally went back to doing it the way you did." It's like, well, I suppose I should have documented that better. Sorry, but usually there's a statement by G.K. Chesterton who says that if there's a gate in the middle of a field and you're not sure why it's there, it's best to find out why it's there before you take it down. And similarly with code, if you find some really stupid code, it's best to try and figure out why it's there before you go and just throw it away.
And Scott, this is
Yeah,
very interesting, right? Because the first thing that we imagine, it's about, um, well, this is if someone else did that, so I don't know how it is, right? But what Andres is talking about here is very true. That many times we wrote that piece of code,
mhm,
we forgot why it's there, right?
yeah,
And because we didn't document, and we put the gate in the middle of the field, right?
right,
Um, or maybe we did put the gates, and then the field was built around it, right?
yeah,
And then now we think we can just remove the gate, right? Uh,
right,
we actually had in here in my house, right? We had a funny situation because we had like a pipe that goes in the middle of nowhere, right?
hmm,
And so I was like, "Why we have this thing here, man? Just cut it off."
oh man,
And so we cut it off, and then water start. I have no idea what it's just the water from my house stopped working. So I don't
hmm,
know why the pipe goes where it goes. Right, I would have to excavate my whole garden to
right,
figure out where it's when, but it's there, right? So yeah, I think that sometimes you put it there and you have no idea why it's there, right?
right, right, absolutely. So yes, yeah, and that's again, it's another reason why we want to make sure that the code that we write is clean and easy to read. But also why we want to develop our skills for reading code that's not easy to read, so that we can understand more quickly why things are the way they are.
Cool.
So um, let's get back to this. Why do we read code anyway? You know, the first thing we're going to try and do is, this is probably the main reason we want to read code, is learn how it works so that I can make some change or fix a bug that was discovered in it. Why, how does it work? And that's what we're just talking about. Why does it do what it do? Um, Sometimes we will read code to figure out how does a library or a framework work, and so we want to understand the background of it. I remember when I was first working with the Microsoft Foundation classes that I we would want to make some change, and I would dig deep into the source code of the Microsoft Foundation classes to get it to do what I needed it to do. Um, Sometimes we'll read other code that other people have written so we can learn some new way of doing things. This guy's pretty smart and he writes good quality code, and so I want to learn how he does it so that I can figure out how to do it myself. And sometimes you do it for a code review. It's sort of like when someone hands in their paper at school. The teacher reads it because that's her job. And so you read somebody else's code. It's part of your job. You want to notice the code smells in someone else's code, so that you can be that gatekeeper to keep it from getting into the rest of the code base and adding disastrous stuff to everything else that's already there. So I told you I would tell you about a book that helps you to learn how to read, and that's this book. Felina Hermans is a professor in Delft University, and she has been studying how the brain works. I've always had an interest in finding ways to optimize how to use this tool between my ears. So this book has a lot of really cool ideas and suggestions for how to optimally use your brain, um, as I guess, especially as a software developer, because it's the programmer's brain. And I highly recommend it. So, um, so this is a picture of our brain, and so when you learn something, it comes in as information. It's stored in our short-term memory, which is very small. You can stick like between 5 and 9 items at a time into your short-term memory. Then it moves into your working memory, and from there, it's associated with something in your, in your long-term memory, and then from there you access it and you're able to reference it in the future. So we're going to dig more deeply into this clever system and see how it works, especially for software developers. Now, there's 3 different ways uh, that code can be hard to read. The first thing would be a lack of knowledge. So the code we're looking at here is APL. And it's I learned this when I was in college. We considered it to be a write-only language, and it uses these Greek symbols, so it literally is Greek to most people. My my guess is that this is probably a comment, but the rest of it, who knows? So what makes this hard to read? It's got an unfamiliar syntax. You can't really understand it. It's literally Greek. So I don't have the knowledge that I need to understand this code. I can make a few guesses, but that's pretty much about it. The next thing that makes code hard to read is lack of information. It's I'm not familiar with the specific syntax. Maybe I haven't learned how this lambda expression works in Java yet, because it's just I I've been working on Java 5 for so long, and now we're gonna move forward to Java 9. I'm just gonna keep doing my Java 5 thing, and so or maybe I'm not sure how to use a function and run a function through another class. There's just different ways of doing things that I may not be familiar with, and I don't know exactly how it works. So I've got to figure that out. I don't have the information, even though I should be familiar with it, but I'm not, because I'm just not educated enough. And finally, there's just lack of processing power. You've got this complex algorithm that I have to work through. I just can't keep all of this crammed in my brain at the same time. All the variables and operations that are in here are just hard to follow. We say that has high cognitive complexity. Okay, so with that in mind, we'll look back at our diagram of our brain, and we'll use this model as a map for how we might overcome these three types of confusion. So you can think of long-term memory as like your disk, and your short-term memory as your RAM, and your working memory might be CPU with a handful of registers. Okay, so running a program in your head is referred to as tracing. So when we trace a program in our head, how does our brain work? Well, first, we're going to read something into our short-term memory. And now we consider that your short-term memory lasts about 30 seconds on the outside. And if you've heard of Miller's magic number, basically, he said that we can remember 5 plus or minus 2 things at a time. And in Felina Herrmann's book, she talks about how actually recent studies show that number is smaller. It's actually 4 plus or minus 2. That may be due to social media. We don't know. But but if you think about it, this is why we have phone numbers. Our phone numbers are divided up into groups of 3 or 4 to make it easier to remember. So how can we improve our efficiency of using this short-term memory? Okay, so we'll have an exercise. All right, I'm going to show you some characters, and I want you to see if you can remember them. All right, I'm going to just flash them on the screen real quick. See if you can remember these. Okay, so that was probably hard to remember. Okay,
Yes. No, zero remembrance.
Zero remembers. Okay. Unless you're from Russia, even then it's just nonsense.
I think there was a fork in there.
That's where actually there are Cyrillic characters. But what we've done here is we've just overloaded our short-term memory with a bunch of symbols that we don't recognize and can't really do anything with. Okay, so now we'll try something a little bit different. Okay, so now that was almost possible. In fact, if you tried to write those letters down, you'd probably be surprised that you would remember more of them than you thought you would. I'll get back to that.
I remember box and car something in the end. So
yeah. So why is it easier for us to remember this? Well, because we have some association with something we already know. We recognize those symbols because they've been stored in our long-term memory as letters. And we know that if we put letters together, we can make words, and we could probably shuffle some of those letters around and make them look like words to make them easier to remember. Okay, so hold that thought, and we'll try this one more time. Okay, so that one was easy to remember.
Yes, okay. Blue sweat shoes. I got it.
Right, woo-hoo! Very good. So why is it easy to remember that? Well, it's because we can associate those letters with something in our long-term memory. Also, we have combinations of those letters stored in our long-term memory. Okay, so that's called chunking. So grouping things together in familiar patterns is called chunking. And so what we've done is we've grouped these letters together, and we've seen these particular groupings many times. And frankly, even we probably have that particular phrase is a song in our head, and that makes it, again, even easier to remember. So back to our brain model. We can increase the effectiveness of using our short-term memory by chunking things. Chunking things that especially we have already in our long-term memory. Okay, so what are some ways we can chunk the code that we read so that we can understand it more quickly? All right, well, um, I've given you one simple tool. What are some others? Well, for one thing, we've got what's called iconic memory. Okay, we read some code and it goes through this filter. And here, I'll show you this bit. So we've got this filter, and this filter represents, whatever it is in your personal life, how you're feeling that day, your personal life experiences, and whatever else might filter things. Um, so before it gets to the short-term memory, it passes through something called the sensory memory, and you can think of that as sort of an I/O bus. So when you see something really quickly, like we did earlier, you have a sort of mental picture of it, and that's stored in a special part of your short-term memory called iconic memory. And from here, you can make very quick associations with your long-term memory. And when I said that you probably remember more of those random letters than you think, that's why. So you may have seen pictures like of people drawing pictures on a camera where the lens was left open for a few seconds, and this is called a persistence of vision. And that's really what this iconic memory is. We just kind of have a picture of something in our mind. Okay, so how can we use this? Well, think about that. If you're an experienced developer, what's the first thing you do when you're looking at unfamiliar code? Well, you're first going to glance at the shape of the code. Okay, it'll give you some idea of the structure and the design. And this little section on the right is from a tool called Code Glance Pro. It's an IntelliJ plugin that I use to help me dig through the code. Okay, so you can just looking at the shape of the code, you can probably tell that, let's see, this looks like it might be a switch statement. Looks like these are probably doing very similar things. This looks like it's a couple of if statements. And you can just know that from having seen a lot of code in the past. And yeah, so this would be this case statement here that's highlighted here. So anyhow, so this Code Glance Pro I find it to be a really helpful tool for helping me to get a quick understanding of the general idea of how a code is laid out. And so, like I said, it's a plugin for IntelliJ. If you're using VS Code or Eclipse, then there's a configuration setting in your configuration settings to turn on what they call a mini map. And so I don't have a picture of that, but if you want to do that in IntelliJ, you've got to use this plugin. So what's something else that we can do? Back to our brain model here. We can increase the effectiveness of our short-term memory by chunking. And some other ways we can chunk the code that we read so we understand it more quickly. What's another thing that we could do? Well, one thing that has been done a lot recently, recently, in the past 20 years or so, design patterns, right? So they're an excellent way to attach a large set of information to a single idea or word, right? So this is our publisher subscriber pattern, or it's also known as an observer design pattern. If you know the implementation well enough, you're going to be able to recognize that when you see it in some code, and you're going to know what the original developer was thinking more quickly. So design patterns are a great way to communicate very complex ideas quickly, and it's a really useful skill to have those design patterns in your head so you know what they look like in the code. I used to race sailboats, and when you're racing through the water and you're coming close to a mark in the water that you need to turn the boat around, and the skipper says, "Trim the jib sheet," that's much more useful for him to say than, can you run to the front of the boat, grab the rope that's attached to the front sail, pull it in a little bit tighter so that it's parallel with the mainsail, and then tie it off? It's like, I'm sorry, he doesn't have time for that. He needs to have some quick, short jargon that he can throw at me that I know exactly what he's talking about and what it means, so I can do it quickly without even hesitating, so that we're more quickly going to be able to do the operation we need to on the boat. And in the same way, you'll be able to read code more quickly by understanding the jargon and the design patterns and being able to recognize them in code. Documentation, comments, these can be very helpful. Studies show actually that less experienced developers depend much more on comments than more experienced developers. Why is that? Think about it. A less experienced developer will depend on the comments primarily out of ignorance that the more experienced developer will generally skip over it, because the more experienced developer has been lied to enough times by comments that he doesn't trust them anymore. But if we can have comments that explain why something does what it does, that can be very helpful. In addition, we can have comments that sort of set off a section of code like this. It sets off, okay, this particular section of code does this particular operation. Generally, I would recommend that people turn that into an appropriately named method, but it's also helpful when you're reading code to find comments like this so that you can say, okay, this looks like something that I can turn into a well-named method. Okay, there's also, I guess, the comments that sort of mark off code or a well-chosen method name like that. Those are called beacons because they help the reader to find their way through code. Similarly to how a lighthouse beacon helps sailors find their way on the sea. We have lots of sailing metaphors today. So simple beacons represent a single concept or a single variable name, and a compound beacon would represent combinations of things. Like, a compound beacon would be like a design pattern or a comment that represents a section of code. So why does this matter? Well, when you write your code, make sure you leave beacons. All right, so with that in mind, how do we use what we now know to address the different kinds of confusion that we can run into in our code? Well, our first problem is lack of knowledge. So how do we overcome that? Well, we learn, we research, we study, we learn the syntax of the language, and we add that syntax to our long-term memory so we can be able to start understanding this code more easily and quickly the next time that we see something similar. Right? I can say, okay, so this is an assignment. Okay, so now I can look through the code and very quickly see there's a bunch of assignments. Okay, so that would be like equals in BASIC or Java or something. This is a name of a method. Okay, all right. So, and this little iota it generates a list of numbers. Okay, and this is a ceiling. So this tells me that this is a maximum. Okay, so now I understand how this all works. Okay, and also when you're reading APO, you read one character from the right to the left, one at a time, with no concern for precedence. It's crazy. It's a write-only language, I promise. But if you learn the syntax, now I can start to understand what it is it's trying to do. Or you just read the comment, it evaluates, it determines. Okay, there we go. Lack of information. If I'm unfamiliar with a specific syntax, how can I read this more quickly? Well, I can become familiar with these new code structures and idioms, okay? I can practice them and study them, learn how they work. Again, add that to my long-term memory so that now when I see this funky looking right arrow, I can say, okay, I know what that's trying to do. and I can more quickly understand, or I can say, okay, I understand what this particular uh, piece of code is trying to do. So I can say they're following a particular pattern, so I can understand it more quickly. Now, for lack of processing power, if it's got a sophisticated algorithm that I can't keep all this stuff in my head, how do I understand this code more quickly? Well, this is where you're going to need an external brain extension, right? You need to effectively print it out, step through it, um, keep track of the different variables and the calculations and the function calls. You might use a debugger to make it easier to do this. We'll talk about a couple other tools that can help you get better at doing this. All right, so um, so basically, all of this is about remembering stuff. Okay, well, I guess the first two things were mainly about your confusion is remedied by learning stuff and remembering it. So how do we make that easier? Okay, do we really need to remember stuff? I mean, what's wrong with Google? Isn't that supposed to keep us from having to remember everything? You know, that we got the whole world of knowledge at our fingertips by just having Google right there. Well, the thing is that um, the more you know, the faster it is to learn new things. So as I know things, I'm able to more quickly associate things with my long-term memory. Okay. If I have to stop and look something up, then I'm going to break the flow of what I'm doing. It's like reading a book and I have to go and look up the word every other sentence. It's just really frustrating, and at some point you're just going to say, I don't care about this book, and you're going to throw it away because it's just too much work to read it. And that's why we get frustrated looking at code that's hard to read, because it's I don't have enough of this in my long-term memory. When I get distracted reading something and I have to break my flow, it takes on average 15 minutes to get back to where I was. And that's assuming that I haven't found some interesting article that leads me down a rabbit trail. You bring up, if you bring up Google, it's got a simple page, but maybe it'll have a Google Doodle, and I want to see what this Google Doodle is about. Oh, it's George Smith's birthday. I wonder what George Smith did. Oh, George Smith wrote this amazing treatise in the 1800s. I wonder what that treatise was about. Wait a second, I was trying to figure out how lambdas work. Okay, so if you already have this stuff in your head, you're going to be less likely to start running down rabbit trails that are going to distract you forever. So one thing to consider is that memory has a rate of decay, all right? Our brains remember things through repetition, usually. I mean, you'll remember a noteworthy event like a crisis or a surprise or something, but that's not what we're talking about. Code is rarely a crisis or surprising. Um, we need to repeat what we're trying to learn, but we want to spread out the learning. You don't try to cram things. That has the opposite effect of what we want, because you cram and you get everything in on one day, and you're going to be forgetting it very quickly. And frankly, that's how college and that's how school works. Is we remember stuff for the test and then we forget it. But if you continue to review this material every day for a few weeks, you'll likely remember it indefinitely. And this is called spaced repetition. Now, there's some really interesting tools that help you to do this. Or it's called a flashcard application. And people use them to learn languages. You can use them to learn just about anything. And since a lot of developers are trying to learn a lot of things, chances are good that the thing you want to learn is already available in an existing card deck. So there's this Anki is a very popular one. This is a tool that I've got. And so, if you want to learn how to do JavaScript, you can I pulled this up out of a library. Let me see. Go to AnkiWeb. Where did that go? Here. So you can go to AnkiWeb and you say, okay, I want to get a shared deck. There are all sorts of topics. And if you want to learn about, say, JavaScript. Yes, sir.
Can you zoom in a little bit on the?
There.
Yeah.
How's
Okay.
that?
Cool. Much better. Awesome. Perfect.
Yeah. So if you want to learn about JavaScript, there are literally dozens of decks that are created for JavaScript. So, I pulled one of these up for JavaScript here, and you just work through it, and it will go and help you to walk through. You can look at a here. I'll show you how it works here. So asks you a question. When console logging multiple variables, what can you wrap the call in to log the names of the variables for clearer results? Like, well, I don't know. Well, you can wrap it in curly brackets. There you go. So so basically, it's like having a card, and then you can flip it over and see what the answer is. So all that being said, so you can use, there's Anki and Cerigo and Quizlet are different applications that you can use that will help you to do that. And as you practice, um, like the exercise, like um, like the exercise we did earlier where we were looking at unfamiliar things. This is a similar type of thing. You're going to look at something that's unfamiliar, and you're going to have the answer on the back. Okay, and if you start looking through code and you find something that you don't understand, then you can add a card to your deck very easily so that you can make sure to remember it more easily in the future. Now, one important tip, we remember better by practicing the remembering. I'll talk about this a little bit more later, but if you read the prompt on the flashcard and then try to remember the answer before reading the other side, okay? So you want to, there are two things about our long-term memory. You've got your storage strength, which is the things in our memory tend to stay in our memory. But there's also retrieval strength, which is our ability to recall what we've already stored in our long-term memory. So, for instance, you can think of a time when maybe you forgot your phone number. You know what your phone number is, but for whatever reason, you just had a brain fart and you couldn't remember what your phone number was. And it's in there. It's just you couldn't recall what it was. Your storage strength was fine, but your retrieval strength was the problem. And that's how it is with a lot of things. What you need to work on is building that retrieval strength. And you build that retrieval strength by practicing it. So before you jump to Google to get the answer to a question, try to remember what that answer is. When you're looking at those flashcards, before you flip that flashcard over to see the answer, try to remember what was the answer to it. And that will help you to build your recall strength. Now, one other thing to consider is the concept of elaboration. And that's that we don't necessarily remember things exactly as they were. Our memories are cultured by our experiences and our personal or cultural filters, and details can be altered or forgotten. It's like, was that a short or longhorn? I don't remember what kind of cow. I know it was a cow. So elaboration is the idea of thinking about what it is you want to remember and relating that to existing memories so you can make the new memory fit into the existing long-term memory the way it needs to, so that you're not misremembering things, okay? So in her book, Felina has this exercise that I'll share with you. I picked a really poor color for this. I will We'll fix that in the future. So I'll just walk through it real quickly because I find it really helpful. What concepts does this new concept make you think of? And write down all the related concepts. If you really want to remember something and you want to remember it properly, this is what you need to do. So you write down the related concepts. And then for each of these related concepts, think, why does this new concept make me think of this related concept that I already know? What is it about that? Does it share syntax? Is this similar content? Is this new concept an alternative to the concept that I already know? So um, think about what is it about this new concept that is related to the old concept, and what other ways do I know to write this particular bit of code to achieve the same goal? So create a lot of different variations of the same code. It's sort of like refactoring, but also think about other programming. Maybe there are other programming languages that I know, and do they have this concept built in? Um, or how would I implement this same concept in the other language? For instance, if you're thinking about lambdas, how do I do lambdas in JavaScript? It's very similar, but there's also some differences. And how do they differ in JavaScript from how they're used in Java? Um, Maybe this concept fits into a particular paradigm or domain or framework. So this is just a useful exercise to go through when you're trying to learn, especially if you're trying to learn some relatively complex new concept, like maybe comprehensions in Python, which is a way to sort of generate uh, 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 arrays and vectors of things. So you want to make sure that you remember it correctly. Syntax errors can slow you down and throw you off. So this is a useful exercise. Okay, so back to our brain model. Okay, we've learned how to improve our ability to read code that we don't understand, and and how to learn things and associate stuff from our long-term memory, chunk it up, and associate it with stuff in our from our short-term memory into our long-term memory. All right. So what about code that's just complex? It's too hard to figure out, and we have too much of a cognitive load. All right. So remember, we have our short-term memory. This helps us to remember information by associating it with, it sends it to the working memory and associates it in the long-term memory. So our working memory is used, this is our CPU, this is our RAM, this is our disk. So our working memory is used for processing the information. And working memory is processing everything in the short-term memory. So if we can remember 2 to 6 things in short-term memory, then we got 2 to 6 things in our working memory. So if we try to do more than that, we're going to get cognitive overload. So there are different types of cognitive overload. There's your intrinsic cognitive overload, which is just how complex is this problem in and of itself? Just how complex is it by its nature? And then there's extraneous cognitive load, and what are the distractions that are adding to the problem? What are the other things that are making it harder to understand? And then there's the germane cognitive load, and that's the load created by having to take that information and store it into your long-term memory. Okay, so here's an example. So if you're trying to do a least square algorithm, your intrinsic load is your basic formula. Okay, that's a line. Your extraneous load would be, okay, we've got these variables that we're dereferencing and these functions that we're calling that we've got to go and dereference and figure out what they mean. And then the germane load is finding a way to filter this and condense it down to the essential parts and associate those with a long-term memory so that they're stored and can be recalled properly. Okay? So, we just went over this. Well, we can What you can do to practice this is you can look at a piece of unfamiliar code and consider what is it about that code that that makes it hard to understand. What part of it is intrinsic? What part of it is extraneous? And what part of it is the germane load? Um, so, what are some ways that we can reduce this cognitive load? Well, there's a couple of different approaches we can take. First, since I'm all about refactoring, the first thing you can do is refactor it. You break it up. You can remove the duplication that you see. Um, Turn it into different reusable methods. Make it less readable. Um, just simplify. When you do cognitive refactoring, you want to make it more readable so that you might have to do what's called reverse refactoring, which is known as inlining. You may find method names and variable names that aren't very helpful. You might, like for instance, if you've got a whole bunch of functions being called, maybe you'll want to just inline those so that you can read it from top to bottom, every function, even duplicating code so that you can just see how those calculations are done all in one space rather than jumping back and forth between function calls. In doing that, you might find more useful names because the names that are given aren't really helpful. So you can give them better names. Cognitive refactoring is usually a temporary operation. You might keep good ideas that you find, like better names or something. But the point is that you're just trying to understand what it does. You're not really trying to fix anything or make it better just yet. Again, we're reading code. We're not writing code at this point. Another thing you can do, much like refactoring, is you can replace language constructs that are unfamiliar. If you don't understand how lambdas work or anonymous functions, even sometimes ternary operators can appear confusing. You can expand them out or simplify them, and that can make the code easier to read. Of course, keep in mind that readability is in the eye of the beholder. You do what you have to do for your own understanding, and also remember that any changes that you make are going to be temporary. You can always roll back to how it was before you started. And that's one of the beauties of having a source code control program, is that you can always get back to how things were before you started fiddling with it. Another thing you can do is take these confusing constructs and say, aha, I'll add this to my collection of flashcards so that I can make sure to know how it works next time I see it. If you think about a 10x developer, they're able to work on code faster because they have all this knowledge already at instant recall. And by using the skills we've discussed earlier and these skills, you can grow your skill base surprisingly quickly. All right, so what are some memory aids that we can use to reduce our cognitive load? Well, you can create a dependency graph. What does that look like? Well, you can basically print out the code and find common function calls and where they're used, how they're used, what variables they use in common. This is a tool from Felina's. Felina Hermans has a project called the Code Reading Clubs. And once a month, she'll gather people together from all over the world and they'll read some unfamiliar code. And they have this tool where you can just read it into, it'll read something in from GitHub. And you can go through and analyze the code very easily, put lines on it. But frankly, you could also print it out and get out some highlighters and pencils and draw lines between things. That's what us old guys used to do in the good old days. But by doing this, you can read your code more quickly. So that's creating a dependency graph. You can also use a state table. What's a state table? Well, basically I drew this by hand so that you can see that you can use a piece of paper to do this. You don't necessarily have to have an Excel spreadsheet. But I really have bad penmanship. But basically, you'll write a state table. Say, okay, here's what my initial state is for each of my variables. Okay, and the first time through the loop, everything changes to this. And then my second time through the loop, everything changes to this. And you'll write down each variable and make sure that you understand each step through the process, so that you can have a better understanding of how this works. So basically, you can create a dependency graph. The tool I was talking about is this annotate.codereading.club. I find it helpful sometimes. Again, state tables, a tried and true thing. You write down every value change, and don't skip something, because you'll often find that you get confused, or you'll miss something important. And you can also combine the dependency graphs and the state tables. Doing things by hand will increase your ability to understand things. That hand-eye coordination helps you to learn and understand things in a better way. So here's generally the tools that we can use to help to understand things better. You got your IDE, and that provides indentation, I guess syntax coloring. It'll indent the lines. You got that what was that plugin that I taught, Code Glance Pro, that you can use to quickly understand things. And so there's the IDEs are becoming so powerful to really help us to understand the code that we're reading. So we should take advantage of that. There's always the tried and true paper and pen to understand what it is we're looking at. Your debugger can be very helpful, especially as you're trying to understand a complex algorithm and work through that. Your debugger can help you step through it. Log files, again, another tried and true thing. You can see how the program works and what it does and what the values of things are very quickly. And then, of course, you can run it through your profiler and see the call stacks and how things work. A book that came out very recently that is helpful in understanding how to use a lot of these software tools. It's called Troubleshooting Java. I mention it here. Frankly, the main reason we find ourselves reading unfamiliar code is to find a problem and then go fix it. So this book is a tremendous resource for helping you to use the tools that you have available in your IDE, especially for a language like Java. There are so many tools, and even JavaScript, there are so many great tools. And understanding these tools will help you to minimize the time it takes for you to track down the source of a problem. I enjoy tinkering around the house, okay? And it may take me half a day to do something like hang a door, all right? Or paint a fence or something like that. If I hire somebody to do it professionally, they can have that same job done in 30 minutes. They have to. They have to get to the next job as soon as possible. They can't waste time tinkering around or running to the Home Depot 5 times for that one thing that I forgot, okay? This book, along with the skills that we've discussed earlier, will help to make you more of a professional developer by minimizing the time that you waste trying to understand code, and ultimately, you're able to find and fix problems in it more quickly. Okay? So, in summary, we've got 3 kinds of confusion. There's the lack of knowledge, where you don't know anything about how it works. There's the lack of information, where you just don't understand things well enough, and a lack of processing power, where your brain gets overloaded, cognitive overload from the complexity of a problem. And there's 3 ways to overcome this kind of confusion. You can add information to your long-term memory by chunking, right? By chunking things. You can increase your retrieval strength by practicing remembering things. And you can reduce cognitive load by using external memory helps, like pieces of paper or your software tools in your IDE that help you, like your debugger and your profiler to help you to understand how things work better. Okay. So my challenge to you is to look at the resources at Felina Herman's Code Reading Club site, and frankly, get her book. I only touched a few of the ideas that she has in it, and there is so much more that she discusses, and it's really very interesting, very approachable. Um, I'm I'm one of her fanboys. Okay. Um, Also, you can look at some of the cool code from history. Legacy Code Rocks has this thing called Awesome Legacy Code. Um, you can look through it. They've got things like the code that NASA used for sending the Apollo missions to the moon. Fascinating stuff. How they had to really optimize uh, what it did to cram it all into, like, I don't know, so many thousand bytes of uh, of core memory. Um, there's also like DOS 2.0, or no, think it's DOS 6.0 and Word 2.0. If you want to see some old versions of Microsoft code, um, there's also like games like Galaxian, I think, and what's it? What's the Guten Tag? Wolfenstein 3D. So that's on there too. That's really cool stuff. Also, you know, especially if you're a Java developer and you're working through code, read the JDK. Um, See how the original developers of the language intended the language to be used. You'll find some really cool stuff. uh, read other people's code for fun, especially code that you know is well done. Um, I find, for instance, the what is it? The the Jenkins project. They make it very easy to get in there and start contributing to their project. They want people to help make that project better. So if you go look at Jenkins, you can. They've got it divided up into sections, and they make it very easy to find your way, and and so you can understand how it works and why it does what it does. So just read other people's code and learn things, and that's my challenge to you for taking this information and applying it in your life and becoming a better developer. Um, with that in mind, um, as I said before, you can't really write readable code unless you can recognize poor code. So to that end, I've written a short ebook listing some of the most common code smells and how to refactor them. If you get it, you can also get my daily suggestions on refactoring and writing clean code. And I hope you find this useful and helpful. And that's all I have to say about that.
That's great, man. I learn a lot.
Okay, good.
Yes, all the tools that you showed there. I've got a couple of questions here. So, if anyone has any questions, please feel free to ask. Um, so I'm gonna do this here. Let me take this thing out of here. So, how about I put your book right here so everyone wants you to do that? Yes. How
Okay.
about so you guys can take Scott's book download his book. It's a good introduction to refactoring and how to identify code smells. So just download from there. So Scott,
Yes.
all the tools that you show there, are they all free, open source? Do I need some special things? How does that work?
Um, yeah, all the tools that I showed are free.
Mhm.
Except for like IntelliJ. IntelliJ, and if you're going to be using the professional version, then you'll have to pay money for that.
Right.
But
But
the
you can
plugin I showed was free.
yeah, you can always use NetBeans or Eclipse if
Yeah,
you.
you can use yeah, NetBeans or Eclipse or something.
Yeah.
But yeah, other than that, the tool out at Felina Herman's site is free,
Hmm.
and yeah, the plugin's free. The Anki Web, the flashcard apps, those are all free, as well as I think you one of them, I think you can pay to get extra functionality and that sort of thing. But I think all of them have free a free version.
Cool. Yeah, and I love Anki, man. I know I
Hmm.
use Anki for lots of things. So one thing that I think Anki is underused is as a way for you to remember the things that you want to remember, right? So, I'm always adding cards to Anki, and for example, things that I want to remember for presentations, facts that I want to remember, names of people, names of books, names of authors. So things that I want to remember to tell other people. Then I add all those things to Anki. So then it gets on my daily remembering exercise, right? And so
Hmm.
that's very helpful.
Yes, yes, and I showed that graph of the decay of uh, whatever the memory decay of remembering things, and if you go and review the information just a handful of times, 4 or 5 times
Mhm,
over over a couple of weeks. I mean,
mhm.
that takes you a couple of minutes. I mean,
Right.
combined,
Mhm.
a couple of minutes combined to learn this, and you'll remember it for almost indefinitely.
Right. Right.
And it's amazing how how powerful getting into that habit can be to help you remember things
Yeah,
and really learn things.
yeah, and I think that's it's a tool that you can install on your cell phone, for example, and it will remind you to use the habit. Right? It's just like it's a full tool that really allows you to do lots of things. That's
Yes,
awesome.
yes, very good.
All right,
I have not installed it on my phone. I'm going to do that now.
you should you
I
should.
never, yeah, I just have it on my computer. But yeah, now I don't have to create a reminder on my phone to. I just put it install it.
Yes, it just
Duh.
yeah,
You
right.
learn something new.
Yes, cool, awesome. So, anyone else? Anyone has any questions? I think that was great, Scott. And one thing I want to add. You're talking about the Open JDK. So when I started with Java in way back when, right, in 1995, and the only thing we had basically was the specifications and the source code, right? That's the only thing we had to learn Java from. There's no basically no books, and no one is teaching that, right? So, and it was very interesting because having the source code of Java available at the time, it was not open source at the time, right? It was under a license that you could read the code, you could play with it, but it was not an open source license. But just having the source code available, and it was like this, you know that time Java was smaller, right? So when you download Java, you download with the source code already, right? So being able to play around with source code, add the source code to your debugger, and that was such an awesome. Um, and Java came with its own debugger. It's like command line debugger that would read the source code, so you could see things. So it's like it was really really helpful in learning how Java works and how the JVM works. So I think that this has been fundamental for my career, learning and enjoying reading code. So I
Hmm.
really think it's such an important skill. Um, you said it was very important just because you said many things, but one of the things you said, it was very important because that's something we do a lot, right?
Yeah.
But do you think that reading other people's codes is also good for you to improve yourself and improving your code and writing abilities?
Oh, absolutely. Um, for one thing, I remember when I went to college, um, one of the upperclassmen told me that if I really wanted to learn how to program well, What
Mhm.
I needed to do is hang out in the computer center. This is back in the days when we had a computer center where you had to go to,
Mhm.
and everyone would go there to write their papers or do their computer program.
Right.
I said, go to the computer center and just help people who are having problems. They'll
Oh.
just shout out, "Hey, somebody can you help me?" And you just be there to help people.
Mhm.
You will learn more about the craziest ways that people do things than you could imagine,
Mhm.
and it'll help you to make sure that you avoid the crazy ways of doing, and you'll learn more about programming than you could believe. And he was absolutely right. By watching how other people screwed things up, um, I remember one time this guy had he said, "Yeah, this friend gave me this program. He couldn't get it to work, and I've got a project due tomorrow, and I got to try and get this thing to work." And so I said, "Okay, well, let's take a look at it. Let's go and diagram it out and structure it." Okay,
Mhm.
so this will never work. This will. It's the way it's written. It will never. I mean, you've got everything is on one side, and it's never going to get to the other side. It's never going to. It's never going to work. But I gotta make it work. Well, the way to make it work is to write it yourself instead of trying to take somebody else's code
Right,
and
right.
fix it.
Yeah.
So, but also there are, you can look at Uncle Bob's book here. Ah, he's got all kinds of code in his book. And so you can just go through and see how smart people write good code
Mhm.
and say, okay, this is how I can write my code to look like that code,
Mhm.
assuming you like how Uncle Bob writes his code. But
Mhm.
um But yeah, reading good code will help you become better, and reading bad code will help you to recognize the code smells and then avoid that in your code. So, yes.
Cool. All right. So I see Max saying hello. Hey Max, how you
Hey,
doing?
Max.
Good to see you here, man. Also, Andres saying hello. So hey, Andres.
Andres.
Good. All right. So Scott, I think that's probably enough for today, right?
Oh yeah, yeah. We've covered it all.
We covered it all, right? So, let me just tell everyone that tomorrow I'm going to be running a reputation workshop, right? So
Oh
if you
yeah.
are on my email list, um, just make sure that you join me on the reputation workshop tomorrow. If you're not on my main list and you want to receive daily, you know, tips about career, you can download my ebook right now. That's the best developer year. It's it's a book that has my plan, how I plan my career, so you can plan your careers, right? So, and Scott, thanks very much, man, for being here with this amazing group.
Thank
Um,
you, Bruno.
Everyone for being here with us, and if you're interested in contacting me and Scott, you have our emails because you download the ebooks, but you can also reach us at the Twitters, right?
There you
So
go.
get us here on Twitter, and I'll see you guys. So Talis, oh Talis is I've worked with him long time ago. Hey man, how you doing? Good to see you. Um, that's, let me know how things are going right now. Right, long time that I don't see you. So that's great. Okay, all right. So anything else, Scott? Do you want to first end this here?
No, just practice reading code. You'll get better. I mean, it's an important skill to get better at, and you'll look like a 10x developer as you're able to read code quickly. So
Yeah. Cool. I see Todd is saying that he's doing pretty good. So glad you're here, man. Give him a call anytime, and we can chat and or maybe message me on. I see that he's on LinkedIn. So message me on LinkedIn if you want to chat. If there's anything I can help you with, love to chat and catch up. All right. Okay. Thanks everyone. Good that we have here, and I'll see you guys tomorrow if you show up for the repetition workshop. See ya. See you,
excellent.
Scott.
All right. Thank you. Bye.
Man.